Okay, we're moving on to section 8.6 part 2, and you can see here I'm going to start with example number 4, and these correlate to your homework questions. So the first and second homework questions that you have for 8.6 part 2 are review. So those are 8.6 part 1, and you can use any of the videos or worked examples that you need to from part 1 for numbers 1 and 2. Number 3, I'm going to go back to here in just a minute, but I wanted to start off with this example number 4 because I think I can explain how we write equations of an ellipse in parametric form easier starting with example number 4 than with example number 3. Okay, so we really haven't worked on this in this class. I don't know if you guys have seen this somewhere else before, but the equation of an ellipse looks like this. It's very similar to the equation of a circle, but with an ellipse you have a different, let's say, radius for each part. You have a radius in the x direction and you have a radius in the y direction. So in this case we have x over 6, so we would go out 6 units from the center in this case, which is 0, 0 in the x direction, and then you'd go out 8 units in the y direction from the center, which is 0, 0 in this case. So you see that we have something squared plus something else squared, which is equal to 1. So if you think really hard about all the trig formulas, trig identities that we've done, that should remind you of cosine. I'm going to use t because that's the variable that we want to use with parametric equations. So cosine squared t plus sine squared t is equal to 1. So if we think back to this Pythagorean identity that we know very, very, very well, and then let's relate it to this equation of an ellipse. So let's rewrite that equation of an ellipse, and we would have x over 6 squared plus y over 8 squared equals 1. Now let's write our Pythagorean identity down here. So cosine squared t plus sine squared t equals 1. So what does that tell me? That tells me that cosine of t must equal x over 6. And then sine of t must equal y over 8. Now all we need to do is solve for x and y, and they're going to be in terms of t, and we have our x of t equation and we have our y of t equation. So let's start here. We're going to multiply 6 to both sides. That will give me that x equals 6 cosine of t. Now let's write that in function notation, and it'll be exactly what they have. X of t is equal to 6 cosine t. And so that's, this is kind of confusing here. They just want to know the r value here, but let's just go ahead and write in a whole x of t. So x of t is equal to 6 cosine t. And then for this other one here, we have sine t equals y over 8. Multiply y to both sides, we would have y sine of t. No, 8 sine of t equals y. And then we could rewrite that, so we have y of t is equal to 8 sine of t. And then that's our second solution here. So y of t would equal 8 sine of t. And then that's our answer. So parametric equations are very good for circles and ellipses and those kind of things. Okay, now going back to example number 3, we have a picture of an ellipse, and in this case we have the radius in the x direction is 3, and the radius in the y direction is 5. So as we talked about before, that means our equation would be x over 3 squared plus y over 5 squared equals 1. Now if we relate that right back to our Pythagorean identity, we know x over 3 equals cosine theta, and y over 5 equals sine theta. Also, when you are looking at this picture, notice now What are we going to do to solve for x? We're going to multiply both sides by 3. So we'll have x equals cosine. We should use t there, shouldn't we? Let's use t here. So we stick with our parametric variable. So we would have 3 cosine t and y equals 5 sine t. So when we're going from an ellipse right into the formula for an ellipse, the a is going to equal the radius in the x direction, which in this case is 3, so a equals 3, and the b is going to equal the radius in the y direction, which in this case is 5.